given that v equals this, k positive, maximum velocity of the particle is, so first of all, maximum velocity means the velocity function prime equals 0. So v prime equals 0. We need to find the v prime equals 0. We can solve for t to find the time when the velocity is maximum. So we differentiate the v. When we differentiate with respect to t, we bring the power down. 1/2 times k, the new power is 1/2 minus 1. So this is the derivative. And the derivative of minus 2t is minus 2. The derivative of minus 8 is 0. So this is the v prime. We solve v prime equals 0. Add 2 to both sides. Multiply both sides by 2. And then to the power of negative 1/2 means 1 over square root of. And then we can divide both sides by 4. And we can multiply both sides by root t. So basically we swap here. And we can square both sides to get the t. Now, since the maximum velocity is 4.5, we can plug in this t because this is the time when the velocity is maximum. So velocity maximum 4.5, that happens when the time is, we can replace the time with this. So for the square root of t, we use k over 4. For the t, we use k squared over 16. We have an equation in k here. So this is 1/4 k squared, this is 1 over 8 k squared, and add 8 to both sides, and 1/4 minus 1/8 is 1/8. We multiply both sides by 8, and we take the square root. K is positive, so the k is 10. Verify that v is 0 when t equals, so we have the velocity function. We just plug in the time 1 and 16, and we're gonna get 0. That's it. And find the distance traveled by the particle in the first 16 seconds. So we know the velocity function. We know that distance is the integral of the velocity function dt. So it's maybe tempting to just integrate this from 0 to 16, but that is wrong actually, because previously we know that the velocity is 0 when the time is 1 and 16. Now we don't know the shape of the graph. It's complicated to actually accurately sketch the graph, but we do know that the velocity is 0 when the time is 1 and 16, which means before 1 it can be positive or negative. We don't know, so the shape of the graph can be, for example, like this, which means this is positive, negative, positive, or maybe like this. We don't know and we don't care. So to find the distance, we need to integrate from 0 to 16. So from 0 to 16, we don't know it's positive or negative. Here we don't know it's positive or negative. We just have to split the integration, use absolute value, and we get the total distance. So we integrate twice, from 0 to 1 and from 1 to 16, and we use absolute value. So the integral of t to the power of 1/2 is t to the power of 3/2 divided by 3/2. The integral of t is t squared over 2. The integral of, this is actually t to the power of 0, is t to the power of 1 over 1. And now we plug in 1 and 0 and 16. So when we plug in 1, this is 1, 1, 1. 10 divided by 3 over 2, that's 20 over 3. And when we plug in 1, this is just 2 divided by 2 is 1. And plug in 1, we have minus 8. So this is what we get when we plug in 1. When we plug in 0, everything is 0, so this is 0. And when we plug in 16, use the calculator, replace this with 16, you get this. And replace again with 16, you get this. Replace by 16, you get this. When we replace with 1, we're gonna get exactly the same like this. So that's what we get. And then use a calculator again, simplify. From here we get minus 7 over 3. And from all this thing here, we have 45. Since we use absolute value, this is positive. So actually from here, we know that the graph is negative before 1. And positive from 1 to 16. So that's why we need to split the integration. So for the total distance, we use the positive value of the area under the graph, positive value of area under the graph. So we use the modulus here. This is the final answer. Alright, I'll see you again next time.